Welcome to this series on the top 30 DevOps interview questions and answers. In this series, we will break down the most frequently asked DevOps interview questions, explain their answers in depth, and explore real-world scenarios you might face in an actual interview. We will cover this content in 3 parts. Part 1 focuses on the fundamentals, continuous integration, and branching strategies. Part 2 will dive into containers, Kubernetes, cloud infrastructure, and scaling. Part 3 will focus on monitoring, observability, security, disaster recovery, and incident response. This is part 1 of the series. Here, we will go through the first set of questions, step by step, with clear explanations, practical examples, and probing scenarios that an interviewer might use. By the end of this session, you will not only know the right answers, but also how to explain them with confidence, and how to connect them to real-world DevOps practices. What is DevOps and why is it important? DevOps is a culture and set of practices that bring development and operations teams together to deliver software faster, reliably, and with continuous feedback. In short, it is collaboration plus automation. DevOps removes organizational silos. It introduces automation for testing, building, and deploying software. It replaces fragile manual handoffs with repeatable pipelines. The result is faster feedback loops, fewer surprises in production, and better uptime. Put simply, DevOps speeds delivery and raises reliability by encouraging shared ownership. For example, Netflix deploys features many times per day. They use automated pipelines, strong telemetry, and chaos engineering to ensure reliability. This shows that DevOps is not just tools, it is process and measurement too. If I were the interviewer, I might ask, tell me about a time when DevOps practices prevented a major outage. What happened and what role did automation play? A good answer would describe the incident, the manual step that existed before, how automation or telemetry caught the issue early, the rollback or fix, and the change you introduced to avoid recurrence. The key takeaway: DevOps is people, process, and automation working together. DevOps reduces lead time and increases reliability. Explain the differences between CI/CD and continuous deployment. Continuous integration means frequently merging code and running automated tests. Continuous delivery means the code is always in a releasable state. Continuous deployment means code is automatically released to production after tests pass. Think of a pipeline: code, commit, automated tests, artifact build, deployment stage. In continuous delivery, you have a manual approval before production. In continuous deployment, that manual approval is removed, and automation handles promotion. This matters because businesses decide their risk tolerance. For regulated industries, continuous delivery with approvals may be required. For consumer web startups, continuous deployment reduces time to market. For example, a GitHub Actions workflow runs unit and integration tests. If tests pass, the artifact is promoted to staging using Argo CD. In continuous deployment, Argo CD can automatically promote to production. As an interviewer, I might ask, would you use continuous deployment for a banking application? Why or why not? A strong answer is no. Use continuous delivery with gates and compliance checks because of audit and rollback needs. If I asked how to make continuous deployment safe, you should mention automated tests, feature flags, canary releases, automatic rollback triggers, and observability to catch issues early. What are the benefits and trade-offs of containers versus virtual machines? Containers are lightweight, share the host kernel, and start quickly. Virtual machines provide full operating system isolation, which often improves security but costs more in resources. Containers are ideal for microservices and continuous delivery. They reduce image size and speed up scaling. Virtual machines are preferable when you need strict isolation or to run different operating systems. The trade-off is increased boot time and memory usage. An interviewer might ask, you must host a legacy payroll system and a new microservice in the same cloud account. What do you choose and why? A strong response is to use a virtual machine for the legacy system if it requires a specific OS or has compliance needs, and use containers for the microservice for faster deployments. Secure them with network segmentation and IAM. Best practices for containers include using small base images such as Alpine, multi-stage builds, and scanning images with tools like Trivy. The takeaway: containers are for speed and scale. Virtual machines are for strict isolation or legacy compatibility. Always match the technology to the problem. What is infrastructure as code and why use it? Infrastructure as code means provisioning and managing infrastructure with code and configuration files instead of manual steps. This ensures reproducible environments. You can version infrastructure, apply code reviews, and roll back changes. Tools like Terraform, CloudFormation, and Pulumi allow teams to treat infrastructure like application code. For example, Terraform can create VPCs, security groups, and EC2 instances consistently across environments. If configuration drift occurs, Terraform Plan will detect it. Teams can fix it by reapplying the code. In an interview, you may hear, a developer manually changed a security group in production. How do you detect and fix drift? A strong answer is by using Terraform Plan, AWS config, or drift detection tools. Then remediate by applying the infrastructure as code configuration. For prevention, add guardrails like policy as code using OPA or Sentinel. Important terms to mention are idempotency, which means running the same configuration many times gives the same result, and testability, which means validating and linting infrastructure as code in CI before applying it. How do you measure success of DevOps? The standard approach is to use DORA metrics: deployment frequency, lead time for changes, mean time to recovery, and change failure rate. Deployment frequency shows how often code reaches production. Lead time shows how long from commit to production. Mean time to recovery shows how fast you recover from failures. Change failure rate shows how often deployments cause incidents. Together, they measure both speed and stability. An interviewer might ask, which metric matters most during a crisis? Speed of deployment or speed of recovery? The strong answer is recovery. During a crisis, the priority is restoring services, not pushing more changes. Practical tools include Prometheus for metrics, Grafana for dashboards, and DORA reporting to track these metrics over time. The lesson: DORA metrics show how your team balances speed and reliability. Describe the typical DevOps toolchain you have used. A common toolchain includes Git for version control, Jenkins or GitHub Actions for CI, Docker for containers, Kubernetes for orchestration, Terraform for infrastructure as code, Prometheus and Grafana for monitoring, and ELK or Loki for logging. Do not just list tools, explain integration. Commits trigger CI. CI builds images and pushes to a registry. CD deploys images to Kubernetes. Prometheus collects metrics and ELK aggregates logs. Add secrets management and role-based access control for security. A pipeline example: developer pushes to a branch. GitHub Actions runs unit tests. On merge, CI builds an image and pushes to ECR or Docker Hub. Argo CD deploys to Kubernetes. Prometheus alerts if there is a regression. An interviewer may ask, if your CI process is slow, what do you optimize first? Good responses include parallelizing tests, caching dependencies, splitting long tests into later stages, and running quick smoke tests on pull requests. Always tie tool choice to scale and cost. Managed services save time, but self-managed offers more control. How do you design a CI pipeline? A good pipeline includes these stages: checkout, build, unit tests, integration tests, security scanning, artifact publishing, and deployment to staging with acceptance tests. Quick checks run first to fail fast. These include linting, unit tests, and static analysis. Slower tests like integration and system tests come later. Add security gates such as static code analysis, dependency checks, and container image scans. Only publish artifacts if all gates pass. For example, a Jenkins pipeline might run checkout, build, unit tests, Sonar Cube scan, Trivy scan, Docker build, push to registry, deploy to staging, and run smoke tests. Deployment readiness can be verified with kubectl rollout status. A typical probe question is, your CI takes 40 minutes. How do you reduce it? Good responses include caching dependencies, parallelizing test suites, running fast checks on pull requests, and delaying long tests to nightly runs. Include quality gates. For instance, SonarQube can fail a build if coverage drops below 80%. This prevents regressions. How do you handle branching and merge strategies? Two common strategies are Gitflow and trunk-based development. Gitflow uses long-lived branches for feature, develop, release, and hotfix. Trunk-based development uses short-lived feature branches merged frequently into main. Gitflow is easier for scheduled releases and controlled environments. Trunk-based works best for frequent deployments, continuous integration, and use of feature flags. Feature flags allow incomplete work to exist in production without being visible. A likely probe question is, which strategy do you choose for a SaaS product with daily releases? The best answer is trunk-based with feature flags. It supports rapid iteration and reduces merge conflicts. In regulated environments, teams may combine approaches, trunk-based for most services, Gitflow for compliant sensitive components. The lesson: choose branch strategy based on release cadence and risk tolerance. How do you secure credentials and secrets in CI pipelines? Never hardcode secrets in code. Use secret managers. Inject secrets at runtime. Apply least privilege access. Secrets should be stored in AWS Secrets Manager, Azure Key Vault, or HashiCorp Vault. Pipelines retrieve them at runtime, not from logs. Secrets should be rotated and access logs should be audited regularly. A common interview scenario is, an intern commits AWS keys to GitHub. What steps do you take? A good response is to revoke the leaked keys immediately, rotate or replace credentials, remove the leaked details from the repository history, scan all repositories for other leaks, and enforce secret scanning in pipelines. Implementation example: in GitHub Actions, store secrets in GitHub Secrets or retrieve them from Vault using a short-lived role. Inject them into the job as environment variables. Never print them to logs. Mask secrets in output if the system supports it. Final note: monitor for suspicious use of credentials. Secret management is a life cycle. Create, protect, rotate, monitor, and revoke. We have now completed the first part of our series on the top 30 DevOps interview questions and answers. In this session, we covered 10 fundamental questions. We discussed what DevOps is, why it matters, and how it transforms collaboration and reliability. We explored the differences between continuous integration, continuous delivery, and continuous deployment. We examined containers and virtual machines, and when to use each. We explained the importance of infrastructure as code and how to measure DevOps success using DORA metrics. We also looked at the typical DevOps toolchain, how to design an effective continuous integration pipeline, the trade-offs in branching and merging strategies, and finally, how to secure credentials and secrets in pipelines. The key takeaway is that DevOps is not just about tools. It is about culture, automation, and measurable practices that drive faster and more reliable delivery. This concludes Part 1. In Part 2, we will go deeper into containers, Kubernetes, cloud infrastructure, scaling strategies, and how modern DevOps teams design for high availability. If you found this helpful, make sure to like this video, share it with others preparing for DevOps interviews, and subscribe to the channel. Don't forget to turn on notifications so you will know the moment Part 2 is released.